We are now on topic 8, which is equations and inequalities. This is block 1 on page 223. First thing, raise your hand. What is an equation? What is an equation?
Can I give an example?
Sure.
2 plus 2 equals 5.
2 plus 2 equals 5, okay. Brady, got something else?
Oh yeah. 1 plus 1 and all those and it equals 2.
Okay, give me something other than an example. I could do examples all day long.
Something that ends in an equal sign.
Something that contains an equal sign. The way I remember that is it almost spells equal. So equations must have equal signs. What is an inequality? John?
The subtraction, the addition, the multiplication, the division of integers.
Negative, Joe Schroeder. Yes.
An equation that doesn't have an equal sign?
That would be an expression. An equation that does not have an equal sign is an expression. Inequality.
Something that's not equal. Like
Some-
an equation.
Not necessarily.
Something that's
Compares two numbers, but it compares it in a unique way.
that could be equal, but like in a way not be greater.
Okay, let's think alligators. They're called inequalities. What's the list of them?
Greater than equal to.
Greater than, less than or equal to, or greater than or equal to.
Oh yeah, those.
Some of you are chatting and it's annoying. So those are inequalities. We need to refresh our memory on all of that. So those of us that did not turn in the extra credit out of our book has a blank page. So those of you that have a blank page, record this down. If you don't have a blank page because you turned in extra credit, you'll have to use a sticky note. I'm trying to conserve my sticky notes. So writing this down. Equations. You have expressions that have no equal sign. Equations have equal signs. Then under inequalities, you have a less than, greater than, less than or equal to, greater than or equal to. Then these circles, that's how inequalities are graphed on a number line. You have an open circle that stands for not included. That is your used with your inequality signs that do not have an equal sign, so less than or greater than. A closed circle stands for included, which means something is included there. So if I said a number
I'm sorry.
is less than 6, can it equal 6? No. So that means if I would put an open circle on the number line at where 6 is because 6 is not included. If I can do numbers less than, so is 7 included?
No.
No, is 5 included?
Yes.
Yes. If I said a number less than or equal to 6, is 6 included? Yes. So I would do a closed circle on 6 on the number line. So that is what the open and closed circle stands for. So number 1. Let me get back there. You know how we looked at Archibald and he helped us with number lines and such? We're going to have these alien video game creatures helping us with equations and inequalities. And it says a space alien video game features growing alien families larger aliens have more body parts and more special powers, so they are more difficult to defeat. Mathematical skills and strategies will help you win the game. So here are some different creatures that we're going to be looking at this unit. First, so the first alien family we're going to look at is Crabco family here. And I have the first 3 family members from Crabco. And number 1 in our workbook wants us to draw the first 4 members of Crabco family. So I want you to take a second and draw the first 4. I have 3 of them done for you. See if you can figure out the 4th member. So we have 4 members drawn on our paper. The first thing I looked at when looking at the first and second member of the family, what did they have in common? Yes.
Y'all had a base of 5 and then the 1 on top.
They had a base of 5 and a 1 on top. That's first how I looked at it. But I had to look at it a little differently just to come up with an equation. So I noticed that each person in the family has 2 blocks for arms or crab claws. You see them? And each member, we called it last hour scorpion booty, because he kind of looks like he's got like a scorpion tail on his top. I didn't know what else.
That could just be the spine.
I don't know what it is, but all of them have the top hat looking thing or scorpion tail. Okay, so all of them have 3 of the same body parts, correct?
Yes.
Okay, then I asked myself what's changing between each member. Well, member 1 has a body of how many?
2. 3.
He has a body of 3. How many sets of 3 does he have? 1 set of 3 for his body.
What makes that a body?
Because this was his arm and then his tail. That's just kind of how I thought about it. Or an antenna, however you want to look at it. Okay? Member 2 has a larger body, right? But he still has the 3 same extra body parts. How many sets of 3 does member 2 have? 2. 2 sets of 3.
Because there's 3 down there.
Okay? Then the third member has the same 3 body parts, but its core body, how many sets of 3 does it have? 3 sets of 3. So that's going to help us fill in our table for number 2. So the first family member, everybody has the same 3 body parts, right?
Yes, ma'am.
I have heads down, people sleeping. I'll let your parents know. And I'm moving on. Everyone has the 3 same body parts.
Yes, ma'am.
Okay? But the only difference happening is their core. As the family members go up, they're having a larger core, making them more challenging aliens. Well, the first member here has 1 set of what? Of 3. I looked up. 1 set of 3. So how many body parts did the first member have?
3. 6.
6 body parts.
Oh, so you would add it on top?
What?
Add what on top?
3 plus 3.
Yes. Okay, the second member had the arm, leg, and top. Then looking at its core, how many sets of 3 did it have for its core? 2 sets of 3. Okay, which gave it a total number of body parts of how many? 9. The third member had its arms and its head, or whatever it was on top. How many sets of 3 for its core? 3, and it gave me a total of how many body parts? 12. So looking at what's all the same to come up with my equation, I know I added 3 every time. What else did I do every time?
Add 3.
Multiply by 3. Was this number that I multiplied by 3 the same? No. So what can I call that?
X.
A variable, x. Well, since they told me family member is x, I'm going to use an x. So now I'm able to write my rule, which would be y equals 3x plus 3. I'm not, because they mean the same thing. Okay. Number 3 says, record the tools and strategies that can be used to solve equations. Place a check mark by the ones you have used before. So I went ahead and list some strategies to use for solving equations. So go ahead and list those down. And then we will put check marks if we have used them. So we have patterns, equations, graphs, balanced scale model, number lines, and integer pieces. We're about to go through that. Okay, in the past, before today, have we looked for patterns?
Yes, ma'am.
I'm pretty sure we've looked for patterns, so we'll check that off. Have we seen equations with equal signs?
Yes, ma'am.
Yes, we have. Have we looked at graphs to answer questions?
Yes.
Yes, we have. Have we looked at tables to answer questions? Yes, we have. Balanced scale model.
Yes, ma'am.
Yes, ma'am.
Maybe once.
I don't think I've shown it.
No, because we don't know what that is.
Okay,
It's
so we'll leave
BS.
that unchecked. I haven't shown it. Number lines, have we used number lines?
Yes.
Yes. Integer pieces?
Yes.
So this is basically the whole topic. We're just looking all at it together to answer some questions and look at some differences. And the only new thing we're looking at is a balanced scale model. Okay, so everything should be somewhat reviewed. Well, looking here, first I want to show you, they're looking at a table. We've looked at tables before. Have we graphed tables?
Yes.
Have we plotted ordered pairs like they're doing? Yes. Okay, so they're looking at all the ordered pairs. This is not in your book, you're just watching. This is an example of a balanced scale model. So it's just a scale. Equations have to be equal. If your scale is lopsided, that means your equation is not equal and you've done something wrong. So it's kind of like a
Scale.
seesaw.
Oh, yeah.
Yes,
I used to ride
Okay. So what happens on a seesaw for the other person to be down at the bottom?
You have to be heavy.
Or the force has to be greater so that person is being flung down. So Could they possibly be equal?
Yes.
What's probably happening to the seesaw for them to be equal, Wyatt? What's happening for the seesaw to be equal? Their mass has to be equal, or equal forces. If they both had the legs on the ground, holding them in spot, and that was equal, and they both were strong enough, the same force on the ground, keeping them at that level, their force is equal. Okay, so we're going to look more at a balanced scale tomorrow. We have seen integer pieces and worked with those, so we're going to work more with those later on. Moving to number 4. Number 4 says something about what equations have you used in the past? Something like that?
Yes,
And
F
to
equals
list
C
them.
plus 5.
Well, at the beginning of the year, we looked at mixing paint, and we kind of got tired of mixing paint, right? We were mixing green paint for a long time. We looked at 2 equations, y equals 2b and y equals 3b. What do you think y stood for here?
Yellow.
Yellow, and b stood for blue, and that's what made the green paint. So we looked at these 2 equations, so you can write those 2 down for number 4. Y equals 2b, y equals 3b for number 4. We also looked at selling pizza, and we looked at the difference in delivering pizza and not delivering pizza. And we had 2 equations, y equals 7n, c equals 7n, and c equals 5 plus 7n. How much was each pizza?
$7.
$7. How much was delivery? $5. Did each equation include delivery? No, one of them included non-delivery. So we looked at these equations. Write those 2 down under 4. C equals 7n. C equals 5 plus 7n. Wyatt. Okay, moving to number 5, says name some values that make this inequality x greater than 7 true. Well, can 7 be greater than 7? No, that's why it has an open circle, because 7 is not included. There's a hole in the graph. Okay? So if there was an equal to sign, what would this circle be? Closed, because it could be equal to. So what is some values that's greater than 7? 8. We're listing some. Give me a decimal value that's greater than 7. John, what you got?
27.5.
27.5? Is that on my graph?
Yes.
Is it okay that 27.5 is not on my graph?
Yes.
Why is it okay?
Because you're going to
The arrow tells me it keeps going, and I know 27.5 is greater than 7.1. Is 7.1
Yes.
greater than 7?
Yes.
You had that one, Brady? Give me a fraction greater than 7.
7 1/8.
Ooh, 7 and 1/8. Is that greater than 7?
Yes,
It is. Give me. All right, one more example, Brady.
7 2/8.
Oh, 7
Okay. Okay.
7 and 2/8, or that is
7 and 1/4, 7 and 2/9.
Why do you have to simplify?
because we're math legends in
We're
here.
lazy.
Okay, number 6 is a homework, but I'm gonna set it up and get it started for you. So number 6 says model the relationship between pounds and ounces. Hint, 1 ounce is 1/16 of a pound. Or I could say 1 pound equals how many ounces? 16 ounces. I could say it either way. So filling in my chart, if I have 1 pound, how many ounces do I have?
16.
What is my process to get that answer?
1 times 16.
1 times 16. The process for 2 pounds would be 2 times 16. I'm going to stop there and jump down to the bottom of the table where I have P and N. What is happening every time to P to produce N? It's being multiplied by 16. So what is my equation then?
P times
N equals 16P. Could I say 16P equals N?
Yes.
Yes. I can say it either way. So I think that gives you the equation is the answer to part C. Part B, they want you to graph the ordered pairs. D, E, and F is asking questions about your graph. And that is it for block 1. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, home dogs.